Hi, I'm Ryan Mathews. I'm presenting my analog final project for the University of Wisconsin-Platteville. The design uses a sensor that uses an infrared LED and an infrared phototransistor. The theory is that the infrared LED will shine light through the finger that is pressed on the sensor. In between pulses, the signal that the transistor picks up will vary. The signal that the sensor picks up is run through two different stages of amplification. Each stage has a high pass and an active low pass amplifier. Transfer functions for which are H1 for the high pass filter and H2 for the active low pass. This results in a DC gain of about 10,000. I chose the bandwidth for the filter to pick up 30 to 140 beats per minute pulse, which correlates to 0.52 hertz to 2.34 hertz. The input signal should be roughly 0.05 millivolts, and after running through the amplifier, we should be getting a signal of roughly 0.1 to 0.5 volts, depending on the person. Okay, here's the box I've assembled everything in. On the outside we have the potentiometer setting, which controls the sensitivity on the output. On-off button. Here is the sensor I mentioned earlier. So just the infrared LED and the phototransistor embedded in a cork so that it doesn't pick up any light from the side. It only picks up light that's reflected off your finger. On the outside, I have my outputs here and here. That's where we measure the signal on the oscilloscope. Okay, on the inside, we have our power supply, which is just 4 AAA batteries, giving us about 6 volts. We use LM358 op amp dual package, one for each of the amplifications. On this side we have our stage 1, and over here we have our stage 2. The sensor runs into these terminal blocks here. We have an on-off button and then the potentiometer in the back there. Okay, all you need to do to get this to work is hook up your oscilloscope probe to the outputs like I have here, and then simply place your finger on the sensor and then measure the output that you get from the oscilloscope. You can play with the settings as you need to get to work, but right now it looks like we're getting about 0.2 volts, but it's still visible, so everything works fine.